Hello everyone, this is Mrs. Tinker and we are taking a look today at some graphs related to the coronavirus or the COVID-19 outbreak. Those of you who are in my class, you should have watched already a video that I linked for you to the Khan Academy website, where there is an explanation, an excellent explanation, I think, about how we can estimate the number of illnesses or sick people as compared to the number of deaths from the coronavirus. And you're going to be seeing a lot in the days that you're at home of graphs, a lot of grids in the newspaper and on TV that look a lot like the functions we've been looking at this past week. We are in a section of our material that is about exponential growth, and COVID-19 is definitely an exponential function. One of the reasons that we talk about changing things, staying at home, flattening the curve, is because at some point this has to stop being exponential growth. We need to slow the growth rate down. But the initial growth factor, the growth of this virus, is definitely an exponential function. And so we're going to take a look at it that way. One of the things that I want to do is to kind of give you a good sense of why we cannot really compare this to a flu. We're going to compare them, but it's not the same as the flu. So what I would like you to do, if you're one of my students, I'd like you to take a piece of paper, a grid paper, and recreate the two grids that I have in front of me right now. The one on the left is counting by 200s up the y-axis. The one on the right is counting by 10,000 up the y-axis, and both of them are counting by 5s across the bottom. So the scale across the bottom is 5. So take a minute and pause the video and go ahead and recreate what I have here. I'm going to have you follow along with me and recreate these graphs so we can kind of do a little comparison, and this is actually going to be your assignment for today. So if you've already gone ahead and done the two grids, I want to go ahead and start on the leftmost grid. The leftmost grid, I'm going to label the y-axis as the number of deaths, which I know in the video that you just watched from Khan Academy, there was a good relationship between the number of deaths and the number of people who were sick. And so we're going to recreate that here. The bottom is the days. Okay. So we're going to do two different graphs on this grid, and the first one is going to be with the cases of COVID-19, and I'm going to go ahead and do that in blue. The deaths that occur because of COVID-19, a couple of things that we know about it. And this is an estimate, 1 in 100 people with COVID-19 die. So that is 1%. So if we have one person, we're going to put that on our graph right here at day 0, one person dies. Okay. One thing that we know is that that doubles about every 5 days. Okay. So I have my graph at the bottom here written out in 5s. So that's going to double every 5 days. So if I have 1 here, I have 2 here. I have 4 here, 8, 16. See, I'm not coming up off of that grid much. This is 200. Remember, my first tick mark here is 200. Okay, so that is 1, 2, 4, 8, 16, 32, 64. Oops, I wrote 2,000. That should be 200. Okay, 64, 128, which is going to be just above that halfway point. And then at day 40, you see we kind of take a jump. 128 is going to be up to 256, which is going to be about right here. And then suddenly we're going to be at 512. So that's 2, 4, 512. And then 1024 right? And then 2050. And then suddenly we jump clear up to over 4,000. Let's go ahead and connect those. And then we're going to write an equation for these. Okay. We know this is an exponential growth function, and so our initial value is 1. Our growth rate is 2. But that grows, it doubles every 5 days. So I'm going to say my exponent is x over 5. All right? So at 5 days, I'm going to multiply that 1 times 2, which is 2. At 10 days, I'm going to take that exponent will be a 2. So that's 1 times 4, 4. Okay? Let's do the same thing with the flu. Difference in the flu is that it doubles every about 10 days. And some of the information that I found made it more like 13 days. So we're gonna call it a little bit more aggressive than maybe it is, just for comparison's sake. And we're gonna start at 1 also. So we're gonna double every 10 days. 1, 2 at 10 days. 4 at 20 days. 8 at 30 days. We're still not off that grid mark really at the bottom much. 16, 32, whoops, not there, but here. Ignore that one. And in 10 days, we're still only going to be right about here. Not even, actually, I put that in the wrong spot too, because this is 1, 2, 4, 8, 16, 32, 64. That is actually going to be much lower than that, but we'll just leave it there for now. I think you get the idea. That this is not going very far. The visualization of this, you can see after 40 days, there's a huge difference. That difference of doubling in 5 days as compared to 10 means this thing grows so much faster. The number of deaths increases dramatically compared to this. And the equation for the flu would be y equals 1. Again, we started with 1. Doubles every 10 days. So the exponent would be x over 10. And again, this is the flu. And this is COVID-19. Okay, let's come over to this graph now. This graph is the number of cases or the number of illnesses. Okay, and remember for the COVID-19, for every 1 death, there is 100 illnesses. For the flu, every 1 death means that there is 100 illnesses. Or I'm sorry, not 100, 1,000 illnesses. Because the death rate is 1% for COVID-19, and the percent for the flu is 0.1%. It's a tenth of that, or it's 1,000 people as opposed to 100 people. So we're going to start out in blue again with COVID-19. We're going to do 1. And actually, we're not starting at 1, but it'll be really close to the bottom there. We are counting by 10,000s, remember. For every 1 death we have here, we have 100 people with COVID-19. So that's still, if this is, first tick mark is 10,000, that means this is still not this is not coming off of the grid here, okay? But it doubles every 5 days. So if we have 100 people here, that means we have 200 people. 4, 8, okay, we're getting off the grid a little bit. No, not really. 800 doesn't bring us off the grid because remember this is 10,000. 8, and then 16,3,200, so that's 3,200, right? And then 6,400, which is going to be a little bit more towards the center. And then 5 days after that, 6,400 now becomes 12,800, which is going to be up here somewhere. 12,000 doubled, 12,800 doubled is going to be more like 2,500. So 2 or 10, 20, about right here. Okay, double it again. 25,000 now is going to be up past the 50,000 mark. 5 days later, 50,000 becomes 100,000. And I'm not being really accurate with my numbers, I'm sorry. I'm just trying to give you a general idea so you can see it. 100,000 then is going to double to 200,000 in 5 days. And at day 60, we are up to 400,000, which isn't even on my grid here. And I have this weird bubble because I inaccurately did my graph. So I'm just going to connect the dots, try to make it as smooth as possible. Okay, they look a lot alike. Remember that the two scales are completely different. So we have the scale of 200 for every tick mark over here and 10,000 for every tick mark over here. So you can imagine the flu is going to be the same. It's going to look the same as this one. But let's go ahead and do our equation for this one. Okay. And remember, this is per 100. And the flu is out of every 1,000. So this is y equals 100 people. Okay. And this is still going to be x over 5. Now with the flu, we start out with a much higher number because if for every one death there are 1,000 people who have the flu. Okay, but they double every 10 days. So in 10 days it's going to be 2,000, 4,000, 8,000, and remember I'm only hitting the tens here. Okay, so that's 8,000, and then I jump quickly up to 16,000. Now remember I'm at 10 here, so this is 16,000 about here, and then 10 days later, I'm going to be at 32,000, so that's 10, 20, 32, okay? And then it's going to be 10 days later, I will be at about right here, 64,000. Oops, and that's not right, it would be right here. Now I'm going to go ahead and I'm going to connect those. Do you see how the difference in the exponent, this doubles every 10 days, spreads this out further? Even though the fact that we are doubling, starting with 1,000 here, still makes the difference between these dramatically different. So this one, if we were to make a function out of this, this would be y equals 1,000 because we started with 1,000 people who were sick over here. Remember, that is from the fact that 0.1% of the people who have the flu will die from it. So if you have 1, that means you have 1,000 people who were sick. So that doubles, though, every 10 days. And I just want to point out here the difference in the two graphs. You can see why we have been quarantined, or we've been asked to stay at home to slow the spread. Nothing on both of these graphs looks too dramatic for the first, I'd say month. Although we're talking about, I mean, we're about a month in, and we've been seeing some dramatic things happening. After that point, the numbers start to increase and it looks much more dramatic. And that's what happens with exponential growth. You can start out with something very small. Population growth is like that. I love to use the illustration of bunnies, because bunnies, they will grow exponentially. They have babies exponentially. And the population of bunnies can quickly get out of control, or guppies is another one. And that's what we're dealing with here with COVID-19. Now, one of the things that I want to point out here, I have linked another video for you in the LMS website that also explains 2 other factors that make this grow so quickly and make it a little bit more dangerous than the flu. Number 1, we can't fight off COVID-19 because we've never had it before. The flu is something that our bodies have seen before, and they have developed some ability to fight the flu off. COVID-19 is new. That's where the term comes, novella. And our bodies don't know how to deal with it. The other thing is that we have this exponential growth. It doubles faster. There are more people. The death rate is higher for it, but it spreads so quickly and so easily. And because we have no immunity, that means if we expose someone else to this virus, they're going to get sick, or they're going to get it, or at least be able to carry it. The other thing about that is the COVID-19 virus also doesn't show up in a person, or you don't have symptoms of it for 2 weeks, but you are contagious that whole time, or a good portion of that time. Whereas with the flu, you may have the flu or pick up the flu and only have it for a few days before you realize you're sick. So for 2 whole weeks, you could have the coronavirus and be spreading it around to other people and not even know that you have it yet. And that is what makes it so dangerous. So if you're curious about this at all, the difference between the flu and COVID-19, go ahead and watch that other video that I have linked there. It's an excellent video. I'm not requiring it, but it's definitely a good video to watch. And hopefully this clears up a little bit of the reason why we are being so cautious and why we are trying so hard to be careful with spreading this virus. And as usual, a picture's worth 1,000 words, seeing the difference between the two. And hopefully that helps a little bit. So I will see you guys, or at least talk to you soon, I hope. Miss seeing your faces. Take care.